I have come today with one interesting case of probability. Let us toss a fair coin two times. I have two questions here. First, what is the probability of getting two heads? That is, head at the first time and head at the second time also. And second, what is the probability that we get a head followed by a tail? That is, first time head and second time tail. Are these probabilities the same? Of course, these probabilities are the same, and each is equal to 1 by 4. I see that you are smiling as it is so simple. Now, let me ask another question. Suppose we toss a fair coin repeatedly until we get two heads consequently. That is head, head. The question is, how many tosses on the average would be required for this? Again, if we toss that coin repeatedly until we get head followed by a tail, how many tosses on the average would be required for this? Are the answers of both the questions the same? Based on the previous question, many of us would believe that they should be the same. This would perhaps be our first natural reaction. But in fact, the answers of these two questions are not the same. Let us find the expected number of tosses required in these two cases. First, let us take expected number of tosses to get the first two heads consequently. Let n denote the average number of tosses required. If at the first toss a tail occurs, it means that one toss is wasted and we will have to do n more tosses to get two heads consequently. The probability of this event is half, 1 by 2. And now the total number of tosses required would be n plus 1. If a head appears at the first toss and a tail appears at the second toss, then two tosses are wasted. And in this case, the total number of tosses required would be n plus 2. And the probability of this is 1 by 4. The last case is if we get two consecutive heads. The total number of tosses required is 2 here, and the probability of this event is 1 by 4. Framing these three cases in the form of equation, we get n equal to half into n plus 1 plus 1 by 4 into n plus 2 plus 1 by 4 into 2. N plus 1 is the number of tosses required and the probability for this is half. N plus 2 is the number of tosses required and the probability for this is 1 by 4. 2 is the number of tosses required, that is when we get head consequently first time, and the probability for this is 1 by 4. If we solve this equation, we get n equal to 6. That is, on the average, 6 tosses are required to get two heads consequently. It can be found in this way also. And this is the way what we generally adopt for finding probability and the expected number. The possible cases of obtaining two consecutive heads are first is HH, number of tosses, 2, probability is 1 by 4. Second possibility is THH, first time tail, second time head, and third time head. For this, 3 tosses are required, and the probability for this is 1 by 8. Third case may be HTHH, TTHH. For this, 4 tosses are required, and the probability for this is 2 by 16. Because if we toss a coin 4 times, there will be 16 possible outcomes. And out of those 16 possible outcomes, these two outcomes, HTHH and TTHH, are favorable cases where the event of getting two consecutive heads is obtained. Another case may be H, T, T, H, H, T, H, T, H, H, T, 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 H, H. For this, 5 tosses are required, and the probability for this is 3 by 32. It is simple. All of you know that if a coin is tossed 5 times, then there would be 32 possible outcomes. And out of those 32 possible outcomes, we have these 3 favorable cases, favorable to our event. So the probability for this is 3 by 32. And in this way, we will get the other possible cases also. The expected number of tosses would clearly be 2 into 1 by 4. 2 is the number of tosses and 1 by 4 is its probability. 3 into 1 by 8. 3 is the number of tosses and 1 by 8 is its probability. And so 4 into 2 by 16 plus 5 into 3 by 32 plus so on. When you would simplify, when you would sum this series, it comes to be 6. So number of tosses required on the average for getting 2 consecutive hits is 6. Now, let us find the expected number of tosses to get a hit immediately followed by a tail. Here, if the first toss results in tail, then one toss is wasted. The number of tosses required would then be n plus 1, and probability for this is 1 by 2. If we get first head and second tail on first toss head and on second toss tail, then goal is achieved. The number of tosses required is 2, and the probability for this is 1 by 4. If we get HH, that is head on the first toss and head on the second toss, then the number of tosses required would be n, because there is no wastage of toss here and the process continues. In this way, if we would frame the above 3 cases in the form of equations, we get n equal to half into n plus 1 plus 1 by 4 into 2 plus 1 by 4 into n. And after solving this equation, we get n equal to 4. It can be found in the other way also. The possible cases of obtaining a head just followed by a tail are first maybe HT. Here the number of tosses is 2 and the probability for this is 1 by 4. The other possible case would be THT and HHT. Here, the number of tosses required is 3, and obviously the probability for this case is 2 by 8. Third possible case would be HHHT, THHT, TTHT. The number of tosses required would be 4, and the probability for this would be 3 by 16. 16 is the total number of cases when a coin is tossed 4 times. And out of those 16 total number of cases, 3 cases, HHHT, THHT, and TTHT, are favorable to our event. In this way, the next possible case would be, rather favorable case would be HHHHT, THHHT, TTHHT, TTTHT. 5 tosses are required, and the probability for this is 4 by 32. Thus, the expected number of tosses would be given as 2 into 1 by 4 plus 3 into 2 by 8 plus 4 into 3 by 16 plus 5 into 4 by 32 plus and so on. The sum of this series would come out to be 4. So the number of tosses required on the average for getting tail followed by head, for getting head followed by tail, that is for getting HT, is 4. So in one case it is 6, and in the second case it is 4. The number of tosses, expected number of tosses, are not the same in these two cases. So if you have to choose between HH and HT to win a game, one should always prefer HT to HH. Thank you.